What's up guys, it's me Sir Ernest, and today we're going to solve problem 1-10 of Thornton and Marion 5th edition. The problem reads, a particle moves in a plane elliptical orbit described by the position vector r equals 2b sine omega I hat plus b cosine omega j hat. Letter A, find v, so that's a velocity vector, a, so that's your acceleration vector, and the speed of the particle. And letter B, what is the angle between V and A at time equal to pi over 2 omega. So let's start with letter A. So this is a very simple problem. So we just need to, in order to get the velocity and acceleration vectors, we just differentiate r with respect to time. So the velocity vector will just be the derivative of r with respect to time, or simply r dot. Okay, so differentiating this with respect to time, this would give us 2b omega cosine omega t I hat, and then this becomes minus b omega sine omega t j hat. Okay, so that's it. This is now your velocity vector. Similarly, or in addition, we can get the acceleration vector by differentiating the velocity vector we found or we derived earlier. So differentiating this with respect to time would give us, so this becomes negative 2b omega squared sine omega t I hat minus b omega squared cosine omega t j hat, which we can actually simplify by factoring out omega squared and negative. So this is negative omega squared times 2b sine omega t I hat plus b cosine omega t j hat. And what is this? You will notice that this is this term, or this equation. So that means the acceleration is just equal to negative omega squared r. And what does it mean? It means that if a particle moves in an elliptical orbit, the acceleration of that particle will always be directed towards the center of your object. So for example, if this is your elliptical orbit, so anywhere in the orbit, the particle will always point, the acceleration will always point towards the center, regardless of the position of your particle along that elliptical orbit. Okay, so this is why. And then lastly, the speed of your particle, which is the magnitude of your velocity, will just be equal to v dot v, or just simply taking the taking the square root of the sum of the squares of the components of your velocity. In this case, this will be square root of 4b squared omega squared cosine squared omega t plus b squared omega squared sine squared omega t. Okay, we can simplify this further by factoring out b squared omega squared in this binomial, and then taking that square root, so that becomes b omega. And what we'll be left with is square root of 4 cosine omega squared, cosine squared omega t plus sine squared omega t. We can express this as in terms of only cosine, because remember that if you're going to express sine in terms of cosine in this manner, this becomes 1 minus cosine squared omega t. So in this case, we just combine this with this. So we're now left with the speed of your particle will now be b omega times the square root of 4, or 4 minus 1, so that's 3. So let's put it here. So this is 3 cosine squared omega t plus 1. Okay, so that's it. Okay, so that's your letter A. Of course, you can express your speed in terms of sine. You can do it as well. Now, last part is letter B. So, what is now the angle between B and A at this time? So, in order to do that, let's substitute the time at our, or in our velocity and acceleration function. So let's start with velocity at time equal to pi over 2 omega. So this becomes 2b omega times cosine omega times t, so that's pi over 2 omega I hat minus b omega sine omega times pi over 2 omega j hat. So from here, you can see that omega will cancel with omega inside the trigonometric functions cosine and sine. So what will happen here? So this becomes cosine pi over 2, and this will be sine pi over 2. And we already know that cosine pi over 2 is 0. So this term will actually be equal to 0. And then this term, so the sine pi over 2 will be equal to 1. So our final answer for the velocity at this time is negative b omega j hat. On the other hand, the acceleration at time equal to pi over 2 omega, just substitute this again. So this is negative omega squared times 2b sine pi omega. So this should be omega yes, it should be omega pi over 2 omega I hat plus b cosine omega times pi over 2 omega j hat. So similarly, what we can do here is omega will cancel, and this becomes cosine pi over 2. So again, this will be equal to 0, and this one will be equal to 2b. So that means this will now be equal to negative 2b omega I hat. So the velocity points in the negative y direction and acceleration points in the negative I direction. So that means the angle between B and A is pi over 2 radians, or in degrees. So this is 90 degrees. Okay, that's it. That's our solution to problem 1-10 of Marion and Thornton, or Thornton and Marion 5th edition. Okay, so I hope you learned something today. Thank you for watching, and I'll see you guys in the next video. Bye-bye.